Alright, so I think I'm recording. We're looking at skill packet 3, which is relations and functions. And in skill 3E, I believe it is, that they're asking us to build new functions by adding, subtracting, multiplying, and dividing two old functions. And then we also need to find the domain of these new functions. In finding the domain of these new functions, it introduced a new operation on sets, and that's intersection. And intersection is different than a union in that to be in the intersection, you have to be in both of the original sets. So hopefully we can explain that a little bit better than with this problem. To find the domain of f, well, to find the domain of any function, you start out given an equation, you start out the exact same way every time. The domain is a set of all real numbers, excluding any values that cause division by 0. We don't have any x's in the denominator, so we don't have to worry about values of x that cause division by 0. But we do have a variable that's underneath an even radical. So this 5 minus x has to be 0 or positive. So if we subtract 5 from each side, if we multiply both sides by a -1, we have to change the direction of the arrow. And for our domain of f, we're getting all real numbers that are less than or equal to 5. For the domain of g, we approach it in the same way. There's no variables in a denominator, so I don't have to worry about division by 0. But I do have a variable that's underneath an even root, a square root. So this x plus 4, just like last time, it has to be greater than or equal to 0. If I subtract 6 from both sides, x is greater than or equal to -6. Now, to find the domain of f plus g, I need to take the intersection of these two sets. The domain of f plus g is going to be the domain of f intersected with the domain of g. That's the symbols that you would see, although we don't need to write these out. We don't need to include that in our final answer. But if you're looking at an outside resource, either other videos or textbooks, you would see this idea of intersection written probably like that. Alright, so let's draw a number line. Well, let's draw 3 number lines. One for f, one for g, and one for our answer, the domain of f plus g. So let's keep this domain of f in black. And the numbers of interest are 5 and -6, and -6 is to the left of 5. And then in this purple, we'll have the same window on our number line, so we'll show -6 and +5. And then in our final answer, for the domain of f plus g, we'll use these two pictures to help us describe the set of numbers that are in this domain. So the domain of f was all numbers that were less than or equal to 5. If you took too much away from 5, it was going to be negative. So 5 minus 5 was 0, and that was okay because the square root of 0 is 0. And numbers that are smaller than 5 are going to produce a positive value. So here's a picture of the domain for the function f. Now if we go on for g, we see that x plus 6 has to be greater than or equal to 0, which means that x, it can be -6, but you don't want it to be any more negative than that, because then that would produce taking the square root of a negative number. We need these numbers to be to the right to be bigger than -6. So when we find our answer for this intersection, you have to be in both. The number has to be in this set, and it has to be in this set. So I always start with the numbers here, my boundaries. Is -6 in the domain of f? Yes. Is -6 in the domain of g? Yes. Since I have two yeses, it will be in the domain of f plus g. What about 5? 5 is in the domain of f because it's a solid dot. 5 is in the domain of g, it's shaded. 5 will be in the intersection of these two sets because it's in this set and it's in the second set. Now, numbers that are smaller than -6 are in the domain of f but not in the domain of g. Therefore, they have to be in both to be in my answer. They will not be in my answer because they're not in g. Now, the numbers that are between -6 and +5 are in the domain of f and also in the domain of g. Since they are in both, they're in the top one and they're in the second one, they are in my intersection. And then to the right of 5 is not here, so it won't be in the intersection. So now I have my answer, or at least a picture of my answer, and I need to describe those set of numbers. Well, there's too many to list. There's infinitely many numbers there. And how we describe this interval of real numbers is to use interval notation. And we use a bracket because we're including -6 with that solid dot. It's in the domain of f plus g, and we're including +5. So there's my final answer for problem 4, and I hope that helps.